Hey everybody, Mr. Hames here. Exciting week of recording data to try to find a chemical reaction. Our lab question states, what chemical reaction is taking place when we mix hydrochloric acid, or not mix, react hydrochloric acid with zinc? Well, if I pull up a video here recorded by some students in my first hour, thank you guys, we'll see here that in between these forceps we have a light gray, shiny, metallic, mossy zinc is what it's called. This is zinc. Element on the periodic table, number 30. The element symbol is capital Z, little n. He is dropping zinc into a test tube of hydrochloric acid, which, as you can see, when it falls in there, is some pretty potent stuff. We see a lot of bubbling. We see the zinc starting to break apart. But mostly we see a lot of these bubbles. Now, as we see these bubbles, and we'll get a close-up here, see all those bubbles, there's obviously a gas getting released in this reaction. So the first question that kind of pops in our head naturally is, what is this gas that's being produced? We're seeing bubbling, it's going up and eventually out of the test tube. Another thing that was observed is people noticed that the test tube was hot, started to get warmer. The longer the reaction took place, the warmer it got, in fact. So heat's getting released in this reaction. So what's that called? We're going to get to that, but we know right now just from our initial observations that there are bubbles being produced, the zinc appears to be breaking up, and there's heat being produced. So that is some of our right there reactions. Now you can see right there, it looks kind of funny, looks kind of like a gourd. There's our water balloon. We capped it off to try to catch whatever this gas is. Actually, what ended up happening, this poor group, they went through like 5 balloons. It kept getting holes in it. So I'll fast forward here a little bit to a better balloon. So same reaction, same thing happening, same concept. They have a balloon up here. So whatever that bubbling gas is, they are capturing it in the balloon. Okay. So as we play here, they're just waiting, kind of watching the balloon gradually expanding as more and more gas comes out of this liquid here and enters the balloon. Okay. And what you'll notice here is the zinc is nearly gone. The bubbling has become less severe, less intense, and now the zinc is almost gone. So fast forward a little bit more. What they're trying to do here is they removed the balloon and they're going to tie it off. So now we've captured whatever gas that is inside the balloon. Okay. Now I'm going to stop right there for a second because something important happened here that they did not show in this video. It's not their fault. I didn't ask them to show it. In fact, it probably wouldn't even work with the water balloon. But when I did this in class, I did it on a larger scale with a balloon about this big. And those of you in class might have seen me let go of the balloon and it went floating up to the ceiling. Okay. Perhaps you even saw it in this beginning of this video. Lily was holding her balloon and it went up to the ceiling. So the first piece of evidence that we collect that might tell us what gas is inside the balloon is less dense than the air around it. It's a very light gas. Lighter gases float. The lesser dense gases float. More dense gases rise. Look up people inhaling some of these gases online, not hydrogen. Okay, but like helium, your voice gets high because it's less dense. Helium also floats. There's a chemical called sulfur hexafluoride, which is a very dense gas. There's a Jimmy Fallon episode where they inhale this gas and their voice gets really deep. And that's because it's such a dense gas, it makes their vocal cords, the vibrations on the vocal cords slow down because it's a thicker gas. So it takes more work to travel over the vocal cords, and what you get is a lower kind of resonance in the voice. Anyway, cool sidebar. What's important to note is that this balloon here that he's tying off is less dense than the air around it. Okay, so we're going to hit play again here. Fast forward a little more to get him tied off. Now what he's doing here, this is Nick, I believe, is tying this to his ring stand. Little clamp here on his ring stand. Oh, and now they're going to the tape. That's okay. And then Natalia, what she's going to do is she is going to light it on fire. Reason being is because this is going to give us another important piece of evidence. Okay, so She's getting her lighter lit. Love that she's wearing safety goggles. That is awesome. And let's observe to see what happens now. Oh, couldn't pause it. Let's see if I can go back one little tiny step. There it is. All right. So we had an explosion. All right. And I'll show you that on a bigger scale with Mrs. Peterson in just a minute. So this gas is flammable. This gas is flammable. So we know this gas is flammable. That gives us another major piece of evidence that tells us what this gas might be inside the balloon. Flammable, less dense than air, gas filling up the balloon, and it had to come from somewhere. So think about what elements we started with. So there's some major hints that I gave you that probably are leading you to believe, not believe, know, or conclude what gas is inside that balloon. All right. So let's talk about this a little bit more.
We're reacting hydrochloric acid, which is capital H, capital C, lowercase l. And we're reacting it with capital Z, little n, which is zinc. So right here, this is our hydrochloric acid. It's a compound because there's one hydrogen atom and one chlorine atom that make up the compound hydrochloric acid. Okay? Zinc is an element because it's pure, it's by itself. There's no other atoms that make it up. So the question is, what is it becoming? Well, I'll give you a hint. It's going to be one of two substances. Okay? The other is going to be a liquid solution that we're left behind with. So let's think about this. One of them is a gas, one of them is a liquid. One of them is flammable. One of them is lighter than air because it floats. Okay? The other is a liquid, and we know it's a liquid because it's left behind in the test tube. It is mostly transparent. Sometimes it has kind of a greenish color, but it's see-through. It's a liquid. Okay? So, let's think of the elements going in here. If we are working with chemical reaction, by rules here, whatever's going into the equation has to come out. We can't add anything, we can't destroy anything. Those atoms are going to rearrange themselves to form new substances. So, we have hydrogen. We have Cl, it stands for chlorine, also a gas in its purest form. And we have zinc. Okay? So the question is, how are these going to rearrange themselves on either side? Well, I told the story in class, story of the Hindenburg, a blimp that infamously went down in flames. You used to use hydrogen in blimps because it was less dense than air. It allowed the blimps to effortlessly and easily float. Okay? Well, that turned out to be a bad idea because it's a very, very, very flammable gas. So, you guessed it, this is hydrogen gas. What hydrogen gas looks like is it's H2 molecules, it's two hydrogen molecules. So that's gone. We still have these two left. So what we actually get here is something called zinc chloride. And zinc chloride is that liquid that's left over in the test tube. And there you have it. There is our equation. However, you might notice it's not balanced. We have two hydrogen over here and two chlorine over here. That's an easy thing to fix. Let's just put a 2 right here. And now our equation is balanced. So there you have it. There's what's going on in our hydrochloric acid and zinc reaction. Now, for a little bonus here, we have hydrogen gas in the balloon, right? Now, anytime you burn something, you react it with oxygen gas, right? You have no oxygen, you take that away, and no flame is going to be there anymore. Okay, you want to snuff out a flame, you take away the oxygen that feeds the flame. Okay? Anybody know what we get? Pretty cool. we get water vapor. If I balance this out, we have 2H2 plus O2 is going to equal 2 H2O molecules for a total of 4 hydrogen on either side and 2 oxygen on either side. So pretty cool that. Wouldn't that be awesome if we could wouldn't that be cool if we could figure out how to harness hydrogen as part of a hydrogen fuel cell in cars, and then we'd only be producing water vapor as a exhaust. Pretty neat. So there you have it. What we're going to conclude with is Mrs. Peterson blowing up a really big balloon. I'm out of here. Have a great weekend, and we'll see you Monday.